I think it's highly necessary that there be, as I was saying before, an objective discussion of knowledgeable people about what are the actual problems that the division is capable of attacking. That really seems to me is the difference between leadership and management, the words that you were using a moment ago. I have the impression that the people that are managing actually don't have time to think about what the problems are. They're so busy managing that nobody's sitting back and saying, what can the division do that is unique, that has to be done, no one else is going to do it, and we're the people that are especially qualified to do that. Somebody at the top has got to know what the problems are. And the only way you know what the problems are is that you've got to have traveled and talked with the purpose of finding out what the problems are. And then you've got to have a chance to read. And I will bet you $10 that one of the big problems that we've got is that the top management never reads even what we write. Now, for the first 5 years I was chief hydraulic engineer, I read, or at least scanned, every single paper that came through the division for a publication approval. And I knew then what our people were working on. I knew who was learning to write. I knew something about the level of their ability in the writing field, and I learned a heck of a lot about the problems that the division people were attacking. But if you get to the point where the management says that they haven't got time to do this, then something's wrong, because somebody has to have time to do it. And they have to be the people who have some say. Not people sitting aside in the library, but people that have ability to direct. Now, if you can imagine the chief hydrologist actually reading the papers that were coming across his desk for approval, I'll bet you $10 that that hasn't been going on for 20 years. But it sure went on when I was there, I'll tell you. I spent a lot of time trying to find out what our people were doing. And therefore, well, there's another aspect of this. As you know, soon after I became chief, I appointed Walter Langbein as the chief scientist in the division. And that was for the specific purpose of saying, first, you don't have to come through the administrative way to get to a high position. And I think you know that every time that the director increased my salary, I increased Langbein's salary higher than mine, so that I could always say, the chief scientist earns more money than I do. And if you want to get ahead in this organization, you can either come through the route of administration, or you can come through the route of science. But if you come through the route of science, you always have the possibility of earning more than the top administrator. That was a very important thing to do. Now, the second thing was, as having appointed a chief scientist who had no responsibility except to do research and to discuss with me the kinds of problems that come up in research, there was somebody who had the specific responsibility of thinking about what we ought to do. And therefore, I did not alone have to worry about defining our problems. I had somebody who spent a full time doing that. That there was a close interaction between the top manager and the top people who were thinking about what our problem was. Now, I doubt where that goes on, too. I have the impression that were you to bring in an experienced scientist into the top echelon, that experienced scientist would not be given the job that was given to my chief scientist, but rather would be simply overwhelmed by the administration. I suspect that that would be the case. And I think that's a shame. So that now, there's another thing. In the Washington office, we had quite a few very talented people in each of the fields. Bob Bennett, for example, one of the really intellectual leaders in the groundwater business. There was W.O. Smith, who people found very hard to talk to, but I found delightful too, because I always learned something from Smith. I had less contact with Roland Carter, for example, but I always admired him because he knew an awful lot about hydraulics and surface water matters. There were people like, people coming through like Doughty, for example. Doughty was very important because he was taking on the job of developing a computational system based on physical principles, and on and on. And at that time, I had the impression that both Langbein and I made a real effort to engage these people in conversation, to find out of these top thinkers what was going on in those fields. I doubt whether that goes on as much as it should. But I think that the administration must take on and keep on top of the responsibility to see to it that the cooperative program is not so divorced from the water problems in the United States. There are many ways to do this, but you have to expend effort doing it, and I don't think that effort is being spent on it now. Even when you spend a lot of time, it doesn't mean that you're necessarily successful.
One of the questions, Luna, that came up from folks putting together the history of the WRD during your tenure is, as you view the Water Resources Division today, what advice would you offer to present management? That's a pretty broad statement, and you can take it if you wish, or you might wish to narrow it.
Well, I have tried to explain how we were thinking about it at that time I was there, and I would say that many of the things I talked about could be taken as suggestions, and let me give a few specific ones. You, Bob Averitt, asked me to come to Denver a couple of years ago and talk to some of your senior people in research. And I brought up in that meeting some of the problems that I perceive we have gotten ourselves into, one of which we've already mentioned, and that is people have stayed in the job too long. They now are overpaid for what they're delivering. Their number of new ideas are not as coming as forthcoming, not as coming as fast as we would like. And what do you do about the situation? And I made several suggestions, and none of them have been followed up. One, even if you can't move a GS-15 out of the position he holds, we could do certain things to improve their production in the division, not in the production in publication, but production in the division. For example, I suggested at that time that you consider the possibility of sending some of those people back to school to sort of rejuvenate themselves and learn some new things about what is happening in the field. Some of them, for example, are behind in, let's say, computers. I would like to ask, for example, how many people in the Water Resources Division are really on top of how you use all the HEC programs of the Corps of Engineers? Now, in the outside field, I know only one, and that's Dave Doughty. And the reason he's on top of it is because he actually developed something very similar when he was in the survey. So that here are new techniques that are being developed, let's say in the computer technology applied to water problems. I would like to know, for example, how many people in the groundwater field in the Water Resources Division are up to the snuff on what Herb Skibitsky is doing in his laboratory in Phoenix. Skibitsky told me, when I saw him a year ago, he said the last program that he wrote for a groundwater consulting thing that he was doing, that the program that he wrote was 6,000 lines. Now, can you tell me how many people in the Water Resources Division do that detailed work to find out how to use the most advanced technology on a groundwater problem? I doubt if there are many. So, in other words, that I'm simply saying there are many things that are going on in the consulting field and in academia that I think are being lost to the Water Resources Division personnel because they don't mix with those people. And the way you get them mixing is to go do something. Go join. Give your time free to some consultant like Skavitsky and work with him for a month and find out what the heck goes on, or come to a university, and on and on. In other words, that there's no use being despondent about the fact that we've gotten ourselves into certain boxes that are hard to get out of. Simply say, all right, let's live with it. Let's now do what we can to find out what contributions these particular people can make to the division as a whole. And contributions do not equal publication. There are many kinds of contributions. Second, and we discussed this at that same meeting, somehow or another management has got to get across to these people that the number of short papers in their bibliography is not the way to get ahead in science, and it's not the way to get ahead in this division. This is the most pervasive, the most it's one of the most difficult areas in present science, in the fields that we're in. This idea that you're going to be judged for promotion or for recognition on the number of short papers you write, that's a bunch of nonsense. That's not the way it's done. The way it's done is to write something complete so that you've done that part and you've done it well. Now, that doesn't mean that you cannot put together a series of short papers into something good. But I'll give you an example. Just in the last few weeks, I've been working over in the sediment program, and I've been working over Emmett's paper on the Helly-Smith sampler. That's an absolutely incredibly good document because it's complete. There's many things that one might forget that were asked in that paper. That's a good paper. It's a long paper, but it's complete. There are many things that I'm not well acquainted with, but the ones that I've been working on recently, one has the impression there are good little things coming out, but they're not being brought together into a whole. I wish I knew more about the other publications that are coming out of the division. It happens to be that I'm working in this rather narrow field, and therefore I see the difference between a rather large and complete paper and a lot of sporadic smaller things. But their management and administration have a role to play. And the role is, gentlemen, you've got plenty of freedom. For goodness sakes, take a job on and do it properly. And then I suggested, and have long suggested, that each man in the research field keep a file of what I call the great problems in hydrology, in which you can look at what you do, each man looking at his own, and saying, am I really working on things that are worthwhile? Am I really going someplace that is getting somewhere, or am I just nibbling at something? But leaders must have their own ideas about what are the problems. And a leader, to stay on top, has got to seek ways to see to it that he's on top of it. They're not going to come naturally, particularly if he hasn't got time to read.
Luna, tied to this, very much tied to it, is a paper that you published in a recent booklet on the history of hydrology called the Alexandrian Equation, which you talked about a university agency alliance to carry out research and to bring forces together on these big problems. Would you elaborate on that a bit?
Well, we know that that people in different walks of science, walks of life in science, accumulate quite different experience. And the university people see some kinds of problems and not others, and so also it applies to the people in the agencies. Going back to my early work, both in the Bureau of Reclamation and early work in the survey, there were many ways in which it became clear to me that cooperation with university people was very good for all of us. As you know, I spent a good part of my career, my closest colleague, John Miller, was a professor at Harvard. One of my closest colleagues, Red Swallowman, was a professor at Johns Hopkins. And each of these kinds of people brought into our association different ideas than I bumped into. And I found that very useful. And I'm sure that I, from the survey, brought to them ideas that that came out of our data collection program that they probably wouldn't have known about. I honestly believe that there are many problems in hydrology that neither the government officers nor the academic faculty are going to solve by themselves. And I was merely making a suggestion there. Let us build on our past experience in this and make a real effort. Give me an example of that. The WE idea, of course, was born in the geologic division. And an awful lot of the very best geologic work decades ago was done by university people who were employed by the geologic division in their summer time. We took this on in the water resources division and had much less success, I think, than we had in the geologic division. There seemed to be the idea that if you were on WAE, you were all alone. And what I was trying to get across is that don't separate yourself. In other words, associate yourself with the other fellow. Not just you pay me and I will do my stuff, but let us find things we can do together, so that I can bring students to do something that you can't do, and you can bring a whole lot of things from the government service that we can't get in academia. I really believe that that is something that can and should be expanded to the great benefit of all of us. I can think of lots of examples of how that can be done, but I think that the idea is perfectly clear that the WAE employment should not be just to pay somebody to do what he wants to do. It ought to be some way to get the officers in the government agency together with academics to work on something together. That's the thing I think we miss.
What about, we always talk about bringing professors into the WRD to work on sabbaticals, which we've done a number of times, at least in the Denver area and other areas in the research program. What about moving research or WRD people, excuse me, into academia?
Well, isn't that what I'm saying? It's exactly what I'm saying. The thing is that you're not going the opposite direction. For example, last week I was in Irvine on a meeting of the Water Science and Technology Board. And I had a conversation with Moss about a research program. And I said, I think you need a change. I said, you are welcome to come and share my office with me at Berkeley. I will get you all the facilities you need to use the library and that sort of thing. Come on, I said, take 2 weeks or take 2 months and come and join us and come to our seminars and just sit, read, and take time. I would say that's a great opportunity, and there are many people in the survey one at a time that I'd like to have come and share my office with me, because I know they need time off to get really re-stimulated, and so that you have indeed brought some university people in to spend some months or a year in the division, but to my knowledge you've not sent anybody in the opposite direction.
Well,
I may be wrong, but that's...
No, I think that's pretty well true, but at one time we had a number of people at Colorado State University. Dottie was there among them, Carl Nordine. Now, was that under your
yes.
regime? We don't do that anymore. Do you still think that's a good idea?
Yes, but not at Fort Collins. Fort Collins turned out to be a bad choice. But our experience at Arizona was very good. When Metalis and company went down there, I think that was good for everybody. But well, the difference is hard to describe, but as you well know, all of us know, Fort Collins happens to be a university that is very aggressive in promoting themselves, getting lots of money. They've turned out people that primarily gotten into consulting. That is really not the direction I'm speaking of. The direction I'm speaking of is kind of intellectual collaboration, which I think was more true of Arizona than of Fort Collins.
Okay. We do have a person at Arizona. I believe we have one at Woods Hole now. There's only two that I call off the top of my head. There are fewer than you can count on one hand anyway.
But so you remember that that we were aggressively seeking ways to get people out. For example, I started this collaboration with Emory at Woods Hole and sent Meade there.
Yes.
We had a program, in other words, that we started getting into the coastal and oceanographic kind of thing. You remember that I started the best tree ring laboratory in the United States was in the Geological Survey in our division. That fell apart for competition purposes, unfortunately. Competition wrecked that. Not sharing, competition. We had the best hydraulics laboratory probably in the business. And we lost that for a lot of administrative reasons, but the survey didn't follow up and move our laboratory that Bill Emmett and I built to a place that was more permanent. But we were always seeking to go out and do something new. We remember we had a tree ring archaeology program. We were talking yesterday about one aspect of the history of the division, and I remind you that here we sit overlooking Fremont Lake in Sublette County, Wyoming. We, in the Geological Survey, turned Pinedale, Wyoming into one of the central research centers, if you like, in western United States with regard to hydrology. And that has something to do with the question we've been discussing. Remembering what I said, that when I joined the Geological Survey in 1950, there wasn't a man in the Water Resources Division that had ever heard the word geomorphology. And for the first 4 to 5 years that I was in the division, I was the only man who was specifically assigned to do nothing except what he wishes, which meant research. So for 4 or 5 years, only one man in the division had the responsibility to do research. Yet within 15 years, the Water Resources Division was the most outstanding water organization in the world. It was known everywhere. The publications of the Geological Survey produced by the Water Resources Division were the most important contributions in the field of science of hydrology. And the question is, what were the essential elements that brought about this tremendous change in the position of the division? Well, we've mentioned a few of them, but I'd like to summarize what I think were the important ones. First and foremost, the top administrators had to themselves have experience in investigational work. And not only do they have to have experience in the past, but they had to keep up their association with investigational work. And by investigational work, I don't mean just pure research. I'm talking about the whole gamut of investigations, which mean data collection, data interpretation, basic research, applied research, all aspects of the hydrologic business. One of the reasons that the Geologic Division had for many years been as successful as it was exactly what I'm saying. The administrators were chosen out of the investigational cadre. The director himself was a famous scientist. Every summer, as you possibly know, during the time I was in the survey, Director Nolan took a month off in the summer to go to Nevada to continue his geologic mapping. I remember very well he had daily contact with Art Baker, the associate director, and he kept very close touch with the administration. But he was out doing research. He was keeping himself up to date, you might say, up to snuff with regard to his own ability to continue investigational work. Trying to emulate this model, I issued an order that every senior officer in the Washington office, meaning branch chiefs, assistant chiefs, associate division chief, were expected to leave Washington 1 month a year and go do something. I said, I don't care what you do. Go to the field. Go to a district office. Go stream gauging. Or go investigate some little thing that you're interested in. But find out what people are doing in the division. Do you know that I was the only one in the Washington office that followed this stricture? Every month. I mean every summer. I would take a month and go west to continue my own work. But no one else did. Somehow or another, the history, or the way in which officers in the Water Resources Division had climbed up through the ranks didn't give them that desire, you might say, to go and keep up their own work, whatever it might be. And I wasn't excluding data collection at all, because there are many important matters in data collection that one might have gone into. Well, I'll give you an example. One day, I was working on all the gauging stations in Sublette County and adjoining areas, and there's a gauging station over here on one of the tributaries to the Big Piney Creek. It's called, let's see, it's called Big Piney near Mason. Well, I never heard of Mason, and I never found a rancher who ever did hear about Mason. Yet the Geological Survey had this gauging station listed as Big Piney near Mason. Well, I looked up the latitude and longitude, and I went there and walked through the brush, never did find the station. And I came back to Washington, and I said to the chief of the Surface Water Branch, Joe Wells, Joe, I said, there's something wrong with the way we're doing things. We don't have adequate descriptions of our gauging stations so people really can go and find the darn thing. Well, now here's a kind of a thing. You see that any senior officer in the Washington office could have followed up and said, you know, that's important. What are the requirements? This is just a little example. What are the requirements for the description of a gauging station to be published in the water supply paper? We know that if you had the station description, that usually has a map, how to get there, and all that detail. But when you're in the field and you don't have that station description, the question is, wouldn't it be worthwhile for one of us to look into the matter? Are we writing these descriptions in a proper manner? There's a little example. So I'm saying there are things that could have been done, that have been useful things to be done. That was the first requirement, in my opinion, that the top echelon be on top or be acquainted with or knowledgeable about the most important hydrologic problems of the country, both practical and basic. The second has to do with developing a milieu in which understanding rather than competition was the rule. And I cite the example I was talking about yesterday, where Walter Langbein had people come in from the field to work in his office so he could teach them or supervise or watch them, not for the purpose of, in other words, for the purpose of developing people, hopefully, who eventually might be as important as he is. There were all kinds of things that we were trying to do at that time to spread this word. We started, for example, a big training program. This training program now has expanded to the point where it's actually too big. I think it deals the way as I hear it. The training programs that the division gives are sometimes too much, sometimes too precious, it seems to me. But the training program that we developed at that time at least began to satisfy some of the requirements for spreading the word. Third, and I'm not sure that you would agree with me on this, I think it's absolutely essential that the top level of any organization that deals with scientific matters explains itself clearly to the rank and file. What are we here to do? What is our philosophy? I remind you of that 3 or 4 page memorandum I wrote in 1963 having to do with research and publication. And I would call that an eloquent statement of what I was trying to do. I am not embarrassed about saying that in the kind of speeches that Ray Nace and I gave to the division, that we made a real attempt to eloquently state our position, to try to describe what we felt was the mission of the Water Resources Division, to try to explain what the philosophy was. In that memorandum, you might recall that I said what I think is still very important and was absolutely abrogated the day I left office. I said to research people who came in anew, you will have 4 years to do what you want. You will have 2 years in which you will be expected to work on something we think is important, but you'll be assigned to it. You'll have 2 years of administration, and so forth. The idea of spreading people out and mixing them up completely was lost after our administration ceased. I would say that is the most outstanding thing we tried to do, which is different than what happened subsequently. We had sold everybody on the idea that you did these various things as part of your duty. But when somebody felt that they could argue and that they could change your policy at will, and they could persuade the top officers that that was not the way to go, and the top officers didn't either understand or wish to pursue it because it was tough. You were having to argue with people. You were having to say, look, this is the policy, well, this is what we're going to do. And when you got soft-hearted and relinquish your major policy decisions on the basis of the fact that you won't argue for what you think is right, then the organization starts downhill. What happened was the other way around. during the time that I was there, the organization went up, up, up. And you went to Europe, and people would say, when is the next publication of the water supply series or the professional paper series coming out? Where are you people publishing? Are you publishing in the Bulletin of GSA? Are you publishing in Water Resources Research? And we were very important in that. You'll recall at the time that I first joined the survey, the most important outlet for publication of hydrologic short papers was in the transaction of the American Geophysical Union. I belonged to the American Geophysical Union since 1932. And we were great supporters, Walter Langbein and I were great supporters of AGU. And gradually, hydrology became so important that the people in geophysics and other parts of the Geophysical Union felt that we were getting too big for our britches. And therefore, they finally persuaded the top dogs that they're going to change the journal and have it called the Journal of Geophysical Research. And we were all essentially blocked out. Through Walter Langbein's help with Waldo Smith, we finally made the union agree that they would publish about once a year one volume devoted to hydrologic papers. Well, that wasn't satisfactory. So the time came when we, in the Geological Survey and the Water Resources Division, led the way to develop and sell the new journal, which is called Water Resources Research. The Geological Survey did this. Now I ask you, what has happened since then? Do we take leadership in the question of publication? I fear that we do not. When it takes how many years to publish a professional paper now? No, the leadership is what we're talking about. And leadership means a lot of different things. Leadership has to do with the top administrators have to have sufficient knowledge and be sufficiently close to the field of science that they're in, that they can actually see the way the thing has to go and develop new ways to see that it goes that way. Let me give you an example. We had become so important in glaciology, groundwater, certain aspects of water quality, although we've expanded greatly since then and we're much better off than we were at that time. But nevertheless, we were doing very well in water quality in the 60s. Obviously, in surface water hydrology, we were very important. Tate Dalrymple, for example, after 15 years had compiled these slides of roughness elements so that you could look at the slide and look at the river and see which value of N that you're going to use. Roland Carter had broken the barrier on the question of how we were going to change from a pen and ink trace in the gauging station to something else. At that time, we spent lots of money, years of research, trying to get an electronic sensor which would follow the trace of the ink pen. Roland Carter came through and said, "That's not the way to do it. Let's get a digital punch machine." They brought the digital punch machine in my office, and we all looked at it. We said, "This is the way to go." We bought them, put them in, and for a long time, we remember we had an ink trace and a digital punch. And finally, the digital punch became so useful and so reliable. We were at the front edge of all of the things that were important, both data collection, data interpretation, everything. I dreamed up the idea that I wanted a series of books. I wanted a book on groundwater hydrology. I wanted a book dealing with geology as it affects groundwater. I wanted a book on floods. I wanted a book on surface water hydrology. I wanted one on the hydrograph. I wanted one on glaciers and ice. I wanted one on sediment transport and rivers. And I went to my very good friend, the famous publisher, William W.H. Freeman, and I said, "Bill, I've got this idea. I can visualize a set of books on hydrology written by people in the Geological Survey that would number probably 15 books. But I said, in order to make this work, it's got to be published by a private publisher, not by the Geological Survey nor by the government." Well, Freeman said, "That's a wonderful idea." He said, "I'll publish it. You bet. You get the books, you get the manuscripts," and he said, "I'll publish it." So I divided the thing up. Mark Meyer was to write on glaciers. Bill Bull was to write on climatic geomorphology. Walter Langbein was going to write on floods. I was going to write on rivers, and on and on and on. So at that time, we had just made the change when Director Nolan had retired and Bill Pecora became the director. And I took this idea, it completely worked out with the agreement of the publisher and how he was going to advertise it. Everybody, as a matter of fact, all the authors had agreed to do this. You remember Dick Hadley was going to write on arid zone hydrology. Let's see, the groundwater people were going to be, there's several, and I forget how that was divided up. I took the idea to Bill Pecora, and he said, gee, that's such a marvelous idea. I don't want it published by a private publisher. I want it published by the Geological Survey. I said, Bill, you'll defeat it. I said, you'll never sell it if you publish it by in the Superintendent of Documents office. They'll get no advertisement. It's quite different. I said, let Freeman publish it. No, he said the idea is too good. Well, of course, it broke down. Now, let's see, this is 20 years later. Just about 20 years later. 2 of the books I've visualized are now in press. Bill Bull has written a book, which is now being published by Oxford University Press, called Tectonic Geomorphology. And Bill Bull's second book is called Climatic Geomorphology. And that came about from that idea. So I'm saying that the way an organization of our kind gets ahead is you've got to have ideas coming from the top. Some of them may fail, some of them may work out. But if you lose track of what's happening in the field, you're going to be short of ideas from the top. Running an organization like the Water Resources Division is a scientific job. It's not a job of management. Anybody can manage. Look at the people that run the political arms of the Department of Interior. They're managers. And what do? We suffer from the people who are just managers, who don't understand what the Geological Survey does or what it might do. Let's turn it off for just a minute. Ben Jones reminds me that may not be a complete statement. We have to teach ourselves to be managers. Of course, I agree with you, sir. But you spoke of the fact that we needed to maintain an interface between management and science. There's where I agree, indeed. And I'm merely asking the question, how do you develop and maintain this interface? I believe it's by having a certain amount of effort being spent on both ends of it. No, you are correct that I should not talk down the management requirement for an organization of our kind, but I emphasize the part that you said, that there's an interface that we must develop and maintain, but we must do it consciously, in my opinion. And I fear that if we don't do it consciously, the interface won't develop the way we're speaking about it. Well, now there's another thing we tried to do, not very successfully, but I still think it's worth doing, and that is we have to find ways to have the individuals who work in a scientific organization, singly and collectively, continue to, in an attempt to identify the things we ought to work on. What are the principal scientific problems, both scientific and practical problems? How do we keep ourselves up to date on this? How do we review our program. I mentioned yesterday that in one minor attempt to do this, I can remember conferences that I called where the whole purpose was to discuss the major problems of the day. I suppose that my own way of thinking about it was to attack it this way. I tend to think back over what we know in the general field, the general hydrologic field, and what we are taught in school, and to try to identify those areas or subjects in which the schooling doesn't quite agree with what you see in the field. And that's a hint as to something that's really worth doing. After I left the office of the chief hydrologist, and I only had a dozen or so years of my career remaining, my own approach was as follows. I've attempted to figure out problems that were unsolved that I thought were important. And in that next 10 years, I tackled 2 of them. There were others, but 2 I tackled. One, no one had really been able to measure bed load. And I decided that was something that was worth doing. No one had ever done it before. And if it was going to be done, it was going to be done by the Water Resources Division. Secondly, we were taught in geology that when you change the level of the base level, that everything changes upstream. And we know that that's not true. And I decided that there's a problem that no one knew how to solve, still isn't solved, because my final paper on that is not at all agreed to by many scientists, and yet it was a point of view. The bed load project developed here in Pinedale, Wyoming, turned out to have a side effect which was probably more important in a matter of fact than the major project, and the side effect was the calibration of the Helly-Smith sampler that was done by Bill Emmett. Nevertheless, here was the first, and at that time only, experimental setup designed specifically to measure all the bed load moving in a stream. I'm told that there are certain people in the Water Resources Division that, well, that was a data collection program and really shouldn't even be classified as research. Well, I disagree with that, because I have said before that you can't do research without basic data. And if you can call the bed load project anything you want to, call it research or call it basic data, nevertheless it was an experiment which worked. Since that time, there have been 3 other such experiments, especially the one in Britain, the Reed-Fosdick measurement of bed load. But we were certainly the first. And each of these experiments has added significantly to our knowledge about how bed load moves. Why we weren't more successful in the 1960s in trying to get everybody in the research organization to think about what are the important problems, I really don't know. We made attempts to try to bring people together to talk about important problems, and yet our effort was not entirely fruitful. One of the things that I think any scientific organization of ours should continue and promote is exactly this: bringing people together to discuss from their experience what are the important problems. Now, if you just look around, I can't define yet what these important problems, how they should be framed in terms of a research project. But let's ask ourselves a few of the things that have recently been altered in the last 2 decades. I was asking the question rhetorically, what has happened in the hydrologic arena in the last couple of decades that perhaps alter our view of the important things to look at? Just off the top of your head, you can name a few. The problem of acid rain being one, the problem of the movement of contaminants in groundwater, and of course the Geological Survey is doing a lot of work on that. Disposal of radioactive waste has gotten to be very important. But then there are other problems that are important in hydrology, but they may not be for us. And I remind myself of the advice that I give to a graduate student who's attempting to choose a PhD program. I say, first thing to ask yourself, I say to the student, is this problem worth working on? Is it important? If I solve it, what would be the result? Is it something that will be carried on? Will there be a sufficient interest to carry it to another stage? Then, are you capable of doing it? Do you have the skills to attack this problem? Next, does it have a time frame that's appropriate? Don't take on a PhD program that's going to last 30 years. Do you have the equipment or the money or both to carry forward the research? If you can answer yes to all those questions, then fine. Now, one of the most important things that's happening in the world today is the question of climatic change. And if you look at the literature that's being published and has been published already by the National Research Council, climatic change is indeed a very large problem, and it involves the interaction of surface water, oceans especially, and the atmosphere. Now that's the kind of question, in my opinion, we should look at pretty carefully before we decide that's for us. Because we're not equipped meteorologically to deal with that question. We're not specialists, for example, in the quality of radiation. And yet I hear that this is now being considered to be an important program being developed in the Water Resources Division. I think that could be looked at very carefully. But I must merely cite this as an example of how important problems should be chosen by scientists in the division. I spoke about the question of the atmosphere, which is so important in maintaining an organization dealing with scientific matters. In that 1963 policy memorandum that I spoke of, I made it very clear that the intellectual atmosphere needed for an investigational organization such as the division is not ready-made for you. We, the scientists, must make it, and we must maintain it. It is not handed to us in a silver platter. We must build an intellectual milieu in which we can all work. And that is something to which everybody can contribute. But we're not going to contribute to that atmosphere in the spirit of antagonism and jealousy. The surface water people in the data collection program must realize that they have such an important part to play that they can well deal on an equal footing with the research person. And the research person must make it very clear that he's not looking down on the man who's collecting data. The groundwater modeler must not look down on the man who measures wells. And he must have a keen appreciation of what the water quality people do when you got a sample for them and you send it in and say, please tell me what that water contains. A spirit of cooperation is absolutely essential, and the spirit of cooperation can lead to an intellectual atmosphere in which everybody can be happy, without feeling that they are competing with one another, but cooperating. And failing that, the opposite can occur. And people in the same office, down the same hall, are not speaking to each other. That's ridiculous. How does the administration manage to first identify lack of cooperation of that sort and bring the people together and say, look, we have a common goal? That's a management problem. And what you were saying, Ben, that it's a skill that we have to develop. We have to look and see what our management problems are, how they interface with the scientific problems, and make sure that we face them and in a constructive way to improve things that aren't working very well in an organization. There's another reason that I'd like to mention why the top level administrators have got to have some relationship, continuing relationship with the science which they are administering. It's highly essential that if an organization be considered to be on top of its science, the leaders of both research and administration should be the people that are called upon to solve the practical problems. And that's what was going on in the 1960s. I was in Pinedale, Wyoming, midsummer, and at that time we had no telephone. As a matter of fact, the Highland Lumber Company here in Pinedale put in a special phone because I had so many telephone calls that people were calling to talk about things. And there was a telephone call from Washington, and someone from the company drove out to my home and said, somebody in the White House in Washington is calling you. And they're still laughing about it because I said, tell them I'm too busy, I'll call them tomorrow. And that's what happened, and I called back, and it happened to be the Undersecretary of Interior calling from the White House. And he said, we're having a lot of trouble down in Florida, and I want you to go down there and look into it. They want to build a tremendous airport. They're going to build an airport larger than the airport of J.F. Kennedy in New York. And you know, we're in, the Park Service is administering the Everglades National Park, and we feel that something might happen to it. Well, I said, Mr. Secretary, I can't do it right now. I said, I'm busy, but I'll do it 2 weeks from now. I'll come in and I'll go down and see. Well, this is an interesting story about cooperation. I went to Washington, spent a day, and went down to Florida, and I met people from the Fish and Wildlife Service and the Park Service and the Geological Survey and several other organizations. And one man in the Fish and Wildlife Service, Art Marshall, one of the most important scientific characters in the Fish and Wildlife Service, was really sort of on top of what was going on. And he and I worked very closely together on this. And so I called these people together, and I said, the Secretary wants me to make an investigation. I'd like to get some data, and so I want each one of you to write out a portion of a projected report which defines what you know about how such a jetport would influence the things you know about. For example, one man was an expert on the Florida kite, the rather rare bird. One man was important in alligators. Another was important, knew a lot about fire. And I said, all right, now we're supposed to write this report with the Department of Transportation. I said, I want the Department of Transportation to write up a question of bird kills by airplanes, and I want to know something about noise level. And I said, I'm coming back here in 6 weeks. I have to go back to Wyoming. I'll be back in 6 weeks, and I'd like to have everybody write up what you're going to do, and I want about 2 or 3 pages from each one of you. Now, I said the Secretary of Interior has directed that this report be in his office on the 1st of October. And I said, this is middle of August. And therefore, when I come back 6 weeks from now, we don't have much time. So 6 weeks later, I came back into Florida, called these people together, and I said, now will you hand in the thing that you wrote? And nobody nobody had written anything. And now it was mid-September, and we had something like 3 weeks to go. So I said, very well. I said, I want 3 secretaries, full-time, with typewriters. I want an office devoted to nothing but this. And since I had talked to a lot of people, I sat down and wrote the report. I dictated the report in about 12 hours, including all the parts that they were supposed to write. Well, now here was a situation in which a leader of the Geological Survey was being asked to do something of national importance. And it was not our specialty, but our administrators had to be in a position that they could see the whole field of hydrology, including the biologic as well as the physical aspects, and put it together. And as you know, that report was the first environmental impact statement. Was copied forever after that. It was called The Environmental Impact of the Big Cypress Jetport. And that was the first environmental impact statement. Unfortunately, what happened after that was that the Water Resources Council took our report and they wrote a set of guidelines as to what was to be in every environmental impact statement after that. They actually took the outline out of the Florida report, and they demand that this is the outline that everybody use. And it's terrible because that's really not the way to write a report, is to have somebody force an outline on you. All right, take another case where the Water Resources Division was called upon to deal with a highly important matter of national interest. I had a call from the Secretary's office saying, we're about to issue a permit to build the Alaska pipeline. And there seems to be something peculiar about this. Seems to me that we don't have much information. I wonder if you'd look at the report. I said, surely. They said, we'll send it over this afternoon. Well, the report on the Alaska pipeline consisted of a series of maps showing the location of the pipeline. The maps were folded, and when they folded, the series of maps stood 3.5 feet high. They brought them into my office on a cart. And on top was a little thing about 1/3 of an inch thick, which was the report, the text report. Well, I looked at the maps and I opened up the text report to see what it had in it. And I said to the man, how long do I have to review this report? And he said, the Secretary of Interior says you got 15 minutes. So I opened up the text of the report, and in there was a cross-section. The cross-section, if you can believe it, was 1.5 inches wide and 1.25 inches high. And it showed a round pipe, ground surface, and gravel. And that was what they were going to build the Alaska pipeline on. So I said, very well, I've got my 15 minutes. You take the report back to the Secretary. And I went to see the Director, and I said, Director, this has got to be stopped. They never mentioned permafrost. They have no idea of downslope motion. They have no idea about what soils do in the Arctic. And here, the Geological Survey has all kinds of expertise on this. I said, you cannot allow them to issue this permit. He said, well, I think we ought to make an investigation. Would you do it? And I said, yes. I said, I'll do it with one caveat. I said, I want to take our own plane, and I choose my own people. I said, I want Herb Skibitsky to fly me from our Phoenix office, and I want Bob Curry from the University of California, Santa Barbara, who has spent a lot of time in the Arctic, to go with me. He said, that's fine. So we went up there. And we came back and wrote a report. And that's another funny story. But anyhow, the report ended up carrying only my name, not the 3 names that I put on it initially. But the report stopped the Alaska pipeline for 5 years, because the Geological Survey then, on the basis of our report, said, look, you must go into these details about what happens to the caribou, what happens to the wolves, what happens to the bears, what happens to the permafrost, the downslope movement of soil. Now, what I'm saying in these examples is The leadership of an organization such as the Geological Survey has to be in a position that they are able and will be called upon because of what we have proven in our own ability. And when we fail to do this, when we don't have leaders that are being called upon, then we are losing to other organizations the ability to maintain our leadership. So, and I'm not saying this simply as self-aggrandizement. I'm simply saying this was the position that the Water Resources Division was in the 1960s. And I maintain that that position is so important to maintain that we should do everything we can to examine the nature of our program, our management scientific interface, as you speak about, Ben, how we are getting new blood into the organization and how it's being integrated into the problem. And I'm simply saying that in the period when Ray Nace and I and Al Fiedler and Joe Wells and Ade Williams and Phil Lamoureux, and when that group was running the outfit, we were the people that were called upon. And I'm simply saying that if you look back at the policies that we had established, those policies are worth thinking about and seeing to what extent they have applicability now. One of the things that was very successful, although not greatly appreciated at the time, was that when we hired a new person who was going to be involved in the research program, he was required to spend not less than 2 months, and preferably 6 months, in a district office. In other words, he went out stream gauging, or measuring wells, or collecting samples, and in that manner, many of the new employees that came in, particularly those that had just finished a PhD that we had paid for, they were required to find out what the district offices do and to learn, at least in a rudimentary fashion, the techniques that are used, for example, for stream gauging or water level measurement. And if you look at the number of people that the Geological Survey, that is the Water Resources Division, actually sent through graduate school to earn a PhD, many of these people have turned out to be sort of the top technical people in the game. Not all of them, but most of them have. This was one of the ways in which the division went out of its way to expand its capabilities. Giving now, remember, now we're giving to young people something very special. They didn't have to ask for grants. They were sent to school on salary. And then there was another thing that I learned quickly, that when we put a man through graduate school, there wasn't any use assigning him to a new job for a whole year. When a person finished a PhD, he was bound to determine to spend a year continuing on that subject that he used for his thesis. And matter of fact, we got a lot out of this. You remember when I hired Mark Meyer, the way I got him, because he was really very anxious to go to a university, was I gave him a year at full salary to work on his thesis ready for publication. So that there were things that we did to bend logic, if you wish, to accomplish certain ends. Those kinds of activities are worth contemplating. I had a program, you recall, that I wanted one person from a foreign country to be on our staff constantly. It started out that I hired George Dury from Birkbeck College in London, who came to Washington and then did work in a variety of places in the United States. But he was very popular. Everybody liked him very much. He made a lot of friends. And as a matter of fact, lifted him from a position in England where he was under constant attack by engineers to a position of leadership, which then led him to take a professorship at Sydney in Australia and then come back to the University of Wisconsin. Then the whole question of bringing Bagnall over. Bagnall is one of the really great and famous physicists in the world, and he was on our staff in one form or another, actually not earning a salary, but in a consulting capacity, where we primarily were paying just expense account. But Bagnall came over for the Geological Survey on, I don't know how many occasions, at least a half a dozen, I presume. Then there was Mike Kirkby, one of the most well-known men in the world now on hill slope hydrology. He's a professor at Leeds. He came over. Then we had Asher Schick from Israel, to name some of the people that we had. The whole idea was, again, to build an intellectual climate by bringing people from foreign countries to work with our men and women so that there was spread information and learn from others. When I always had a problem with the people that we had trained, by the time they had worked for the Geological Survey, had earned a PhD at a university at our expense, had worked for us a couple of years, then they became well enough known that they were in constant demand for university jobs. How many did we lose? My goodness, I forget. First there was Wellman, and then there was Brush, and then there was Fonstock, and on, and then Bilbo, and on and on. So in other words, we were constantly losing people that we had trained, losing them to universities. I said that was one of the best things we ever did, because we became, the Water Resources Division became famous in universities, because our men joined faculties and did themselves proud. And they always recognized that the Geological Survey was a high-class organization that got them started. It was worth it to us. And so that I had no compunction about giving the highest recommendation I could to any man who was being proselyted by a university to leave the Geological Survey and join them. Then there's another program that we had that was very successful. It started out that I wanted one of Bagnall's manuscripts to be published as a publication of the Geological Survey, despite the fact that he didn't work for the survey. And I went to the director, and the director was very understanding about this. And he said, surely, if this guy writes a paper that's going to be famous, and it's published by the survey in our series, all the better for us. And so that we had papers, for example, published by, in the water supply paper, and especially the professional paper series, by a series of foreigners, several papers by Ralph Bagnall, a paper by Charlie, papers by Dury, and on. So we had a policy, a general policy, of encouraging at all levels and in all different kinds of ways cooperation with other people, cooperation with colleagues abroad, teaching our own people, learning from the people that we brought over and the people that we collaborated with. All of those things were an important aspect of building the atmosphere of scholarship and intellectualism. Then, of course, I had the well-known geomorphological seminar. Anybody who came to Washington, was going through Washington, well, I could call a seminar in a half an hour, and the people from Arlington Towers had come over, people down the hall had come over. Hell, we could raise a seminar in a few minutes if some well-known person was coming through Washington and simply gave us a ring. And we made a lot of friends that way. because many of our own scientists were not acquainted with some of these people that we were able to ask on the spur of the moment to come to our lecture room and give us a lecture. Now, of the things we've talked about, let me try to just summarize a few of the things that are most important. I started out by saying cooperation, not antagonism. Sharing without jealousy. Recognition of the importance of other people's work by the data collector, who must recognize the importance of research work, and for goodness sakes, the research man, who's got to understand that he is building on the much larger and more extensive data collection program of our division. Leadership in all of its aspects. Leadership in defining the nature of hydrology. And the nature of hydrology has to be defined for people. They don't necessarily know what we mean by hydrology. They don't know how broad we think hydrology is, and therefore they don't recognize what we consider to be the scope of the work of the Water Resources Division. Leadership also means, in my opinion, that the top level people must have a going relationship with things that are going on in the field. And it's not just walking through somebody's office in some distant town. I'm talking about a relationship where they really understand what the district office is up against. Have some personal knowledge about the nature of the problems in a particular state. And one of the best ways to do it, in my opinion, is to actually have investigational work of some sort or another going on personally on the part of senior staff. I can't stress enough what I consider the importance of cooperation and understanding. I've explained earlier that this goes to the point of not being so terribly concerned about turf. We started out talking about that earlier. But rather to concentrate our effort on the things that we do best and have our program chosen by us, not run by the amount of money that it's getting us. We are spending much more time now than I think we did in the 1960s on different aspects of data collection without detailed analysis of how these data are to be used. I'm not able to judge this new program of what you call NACWA. I simply don't know enough about it. But I fear that there's not going on what I would consider to be sufficient investigation with regard to what we need to measure and why we're measuring it. It's like the choice of research program. You could decide, if you're going into a certain piece of research, to collect data on everything that you can think of. That's a very inefficient way of looking at it. You collect the data on the things that you know you're going to use. And if you find that you're missing something, you add it. But don't start out by supposing that you can collect data on everything that might possibly contribute to your investigation. In the start of our research program, I told you that I required the research people to turn in a very, very brief report. But when I said a brief report, I wanted a report that told me why the person is doing what he's doing. And that made him as we've all known for a long time, it's much harder to write a short report than it is a long report. And therefore, in picking a research program or project, we have to be able to put in succinct terms why are we doing this, what is going to be our approach, and what is the working hypothesis we're working on. Unfortunately, we never developed very well what worked so perfectly for many, many years in the Geologic Division, and that was the question of apprenticeship. I wish I had done more on that. It didn't seem to work very well for the division as a whole. It worked very well for us personally. For example, I had a person assistant that helped me in my research. There was Ethel Coffey, there was Bill Emmett, and there was Bob Myrick. And over a long period of time, we helped each other a lot. I believe that those people starting out as apprentices and later getting to be project leaders, they learned a lot from the apprenticeship that we developed between us. The Geologic Division, as you know, for many, many years, the way you got started in the Geologic Division was you were a field assistant to a geologist in mapping. And you name the people that became very famous doing this. The field assistants, for example, under Bill Ruby, all became very well-known geologists. Those who worked, I understand, for people like Jim Galooly, those people became very prominent in the geological business. Somehow or another, we did not develop the apprenticeship idea in our division as much as we should have, in my opinion. As I say, I did personally to a small degree, but I would like to have seen this, the idea of apprenticeship spread, and it's even now not too late. Finally, with regard to cooperation, I'd like to add one thing, that it is not too late, it is never too late, to institute a policy even though the policy has been held in abeyance for many years. The policy that I would think most important to us is some elaboration or some portion of the policy that we talked about a number of times during this discussion. One, a person should be told what his career is going to look like for 10 years. If the man's got research capabilities, you've got 4 years in research, you've got 2 years in basic data, you've got 2 years in administration, and 2 years doing something else. That could be started right now. Our young people should be told, as they come to work in our division, what is expected of them in just those kinds of terms. And the fact that that policy was discarded and has been discarded for 2 decades does not mean that it might not have been a good policy to have continued, and it might still be a good policy to initiate even now. Then, as an elaboration on that, the same thing that Ben was speaking about earlier, when people do move into administration, to use your words, there should be a developing interface between the technical part and the management part. And I can't tell you how to do this, but you have hit upon something that clearly is important, because too many of our people have gone into management and have lost the ability to interface with the investigator, whether it be a data collection person or a research man. So I end up again with stressing cooperation, the trusting and helping each other without the accompanying layer of jealousy And let me mention a couple of things, continuing what we were speaking about before, that are at the moment of great importance in the water resources field. The first one I'd like to mention is of a general sort, and that is the question that has been plaguing us now for 20 years, the river channelization program of the Corps of Engineers and the Silt Conservation Service. As we all know, about 3,000 miles of river channel have already been straightened and deepened by the program of these two agencies. Another, if I recall the number, 4,000 to 5,000 miles of continued channelization of rivers in the United States has been authorized by Congress but has not been funded. Yet there's been no paper by the Geological Survey on the effects of this program. The only well-known paper dealing with the morphologic and hydrologic effects of channelization is by a young Professor Emerson from Missouri, who wrote a paper on the effect of a Corps channelization program 30 years ago. I mean, the channelization was 30 years ago. At the time that he wrote the paper, I think there were 5 successive generations of bridges that had washed out. For 30 years, the river has continued to deepen, and no end is in sight. A program to analyze the channelization activities of the United States government was run under the auspices of the Water Resources Council 15 or 18 years ago, was done by a consultant that, in my opinion, did not do an unbiased job, and we learned nothing. We certainly learned nothing about the hydraulics. Now, here's a problem that lies right smack in the lap of the Water Resources Division. It involves all the things we think we know about: channel morphology, channel stability, equilibrium, flood control, flood economics. No member of the Geological Survey has ever touched this problem. Yet we are continuing, as a matter of federal policy, to straighten rivers and deepen them. I have one example in my book on water and environmental planning, the Pequot River in New Jersey, where the Corps had come in and dug a great trapezoidal channel. And the river within the channel was deepened and enlarged, built itself a little floodplain, and built a self-formed channel within this great cut, which is exactly the same shape and cross-section as the untouched channel upstream. Now here's a morphological problem that involves, I say, all the things that we're interested in. You'd suppose that some part of our program would deal with this problem. Let's take another one. Within the last year, there's a great resurgence, if you like, or increase in interest in what's called water restoration of water bodies, rivers, marshes, estuaries, and lakes. A conference, an international conference, was held this year in 1988 in Berkeley, California, called, under the auspices of Restoring the Earth. It was called Restoration of Water Bodies. The matter came up 2 months later, last June 1988, in a program, a scientific meeting in Lake Tahoe, dealing with the problem of the stability and restoration of high altitude water bodies. I wrote a paper for that Lake Tahoe conference, which I called Natural channel morphology the key to river stability. Here is a problem of growing importance involving all of the basic principles with which we work in hydrology and channels. And to my knowledge, there's been no interest on the part of the Geological Survey. To my recollection, I didn't see any Geological Survey participant in either of the two conferences here that I speak of. Here we are dealing with some problems that the survey has studied extensively. Dr. Kahnemus, for example, of the Geologic Division, was an important author of a paper on the marshlands and also the general hydrology, you might say, of San Francisco Bay. A great deal of effort has been put on data collection and interpretation in San Francisco Bay, and yet the Geological Survey has refused to make any public statements about what our policies ought to be. They present data, but they won't interpret it. We are going through a period of so-called mitigation. I'll give you an example. There's a marsh over near in the Marin County that had been diked. The marsh was destroyed, and the developer wanted to build a big shopping center on part of this land. So he bought it, and the mitigation was that he would give the half of the land that he didn't use back to the state and would cut the dike so that the tidewater comes in and out again. And that was to take the place of the part that he used up for a shopping center. My understanding is that after 2 years, the shopping center is sunk a foot into the marsh surface because no one thought about the problem of the marsh soils being very difficult to build on. Now the floodwaters, the tidewater's going in and out of this place called Muzzy Marsh, M-U-Z-Z-I, Muzzy Marsh. And this is a mitigation method, but this is a general requirement now that you can buy a piece of marshland and give part of it back to the state for rehabilitation, but nobody knows how to rehabilitate it, nor are they making any data collection as to what happens when you let the tide come back. We don't know how long it takes. We don't know what the vegetation comes. We don't know how the channels rehabilitate themselves. A perfect kind of an investigation of data collection and interpretation for the Geological Survey, and we're not doing anything about that. Let's take another one. There's tremendous interest right now in western states, including Wyoming, Colorado, Idaho, that I know of, as well as in California, on the question of in-stream flow. Now, the important court decision that was made in the case of New Mexico some years ago made the following, drew the following conclusion. The federal government cannot use fish and wildlife, aesthetics, or recreation as justification for claiming a water right. They allowed the possibility that the Forest Service could claim a water right based on the wording of the original Organic Act of the Forest Service, which says the purpose of setting aside national forests is to grow timber and for, and these are the words, favorable condition of stream flow. Now what we would like to show is that for the long term, that is for the next 100 and 200 years, we can't continue to take water out of stream channels, dry them up. They will get flooded with sediment coming in from tributaries into the valley. The channel will eventually be destroyed. But we're faced with a hard technical question of what flows are necessary to maintain a channel. For the most part, we think that channels are formed and maintained by bankfull stage discharges. But we're quite unable to say with assurance how many days of bankfull we need. Do we need one, two, several? Does it vary with size of drainage? Does it vary with whether it's a snowmelt stream or some other kind of a stream? Court cases are now in the offing on this very matter. Only one person in the Geological Survey is making any inroads into contributing to this problem. That's Ned Andrews of the Water Resources Division in Denver, with two important papers that he's recently published having to do with the entrainment of gravel. But these papers of Dr. Andrews are collateral to the main subject. They are important additions, but they are collateral. I would be very pleased if there were if there were people in the Water Resources Division that took up this matter from the beginning and said, look, what do we have to have in in-stream flows? What maintains the channel? This is the basic problem. It's a problem of morphology. It's a problem of equilibrium. It's a problem of channel shape, floods, and stream flow. It deals with the whole question of sediment movement, and is a perfect problem for those of us in the general field of sediment and channel morphology. And in this particular case, a very important one, because I say it's coming up again and again in one state after another. Now the question comes up again in another way, but in a comparable way. As you possibly know, legislation was passed that, at least in California, if you wanted to build a hydroelectric plant in the Sierras, the utilities are required by law to buy your electricity. So you as a small operator can go in and build a little hydroelectric plant and know that you can sell your electricity. It doesn't make any difference what degradation you do. And now a lot of people are starting to design small hydroelectric plants, including some of the big companies. But nobody knows when you divert the water out of a high mountain stream in the Sierras and take it around the channel and put it in below the power plant, what happens to the channel in between? What happens to the fish, the recreation, whitewater boating? Because this is so widespread and is no longer limited to California, it now is taking place in several other western states. Here again is a problem. If you change the flow regimen in a river, you're going to change the channel, and we don't know how it's going to change the channel. But we know that the thing is so widespread that basic principles are involved of the kind that we might be interested in looking into. This is what I mean when I was saying there's apparently there's not being a continual review of the nature of water problems in the United States that helps direct the application of the skills of our technical personnel in the Water Resources Division. I would hope that with these emerging problems that the division will take a new look at the matter of how we're spending our time and to what we are contributing. There must also be problems in the field of river biology that I'm not well acquainted with. My problems are, the things I know most about are having to do with channels rather than biology, but I'm certain that there are comparable, probably comparable problems in our biologic work that we might be looking at anew to see what we should be doing. There's another program that has fallen into disuse that I'd like to remind us about. The program is called the Program of the Vigil Network. The Vigil Network is a series of reports, if you like, on places where we have made observations that we would like to continue into the future. They can include such things as river cross-sections or channel cross-sections, profiles, quadrats of vegetation and soils, a variety of things, particularly things that are likely to be changing with time, such as the deepening of arroyos, the alteration of river channels due to climatic change or to anthropogenic processes. The Vigil Network came about because through long experience we found that when we made an observation of something at the present time, 20 years later the notes would have been probably lost or forgotten, and people 20 years from now might want to know what we observed, but they couldn't find the notes. They would not be able to know quantitatively what we saw at our time. So what we did was to set up a place where these original notes could be filed for permanent filing, one in the library of the Geological Survey in Washington, and the other in the Laboratory of Geomorphology at the University of Uppsala in Sweden. I doubt very much whether most people in the Water Resources Division ever heard of this now. I wouldn't even know whether the librarian of the Geological Survey Library even knows where our files are. They should be, our division officers ought to be made acquainted with that file, and some official encouragement be given to research people to add to the file when, for example, what we're doing all the time, we're running river cross-sections, we're making river profiles, we're making pebble counts. We'd like to know what changes occur. I spoke, for example, of the changes that occur in the case of rivers that have been channelized by the Corps of Engineers. There's no program to show what changes occur in those channels after the Corps gets through straightening it. Many of these things, the great importance is to know what happens over a period of years. The changes don't occur immediately. We ought to have a real interest in documenting changes in hydrologic phenomena that occur over time. And we should be the leaders in this. We were the leaders at one time, but now, as I say, I think it's laterally been forgotten. An example, Stafford Happ, the geologist who had worked for many years first in New Mexico, in Georgia, other places in Minnesota. When Stafford Happ heard about our program, he was reminded of the many cross-sections that he had run during his work for the Soil Conservation Service many years ago. And he took a great interest in going back and finding the cross-sections that he had surveyed, 20, 30 years ago. And he made great contributions to the Vigil Network file by putting in the file the original and the resurvey data on cross-sections that he had run separated by a matter of 25 years. Very important things for us to do. Now, we talk about data collection. We find that the research program and the survey, if I understand what you people are telling me, the research program amounts to about 10% of the total of our effort. 90% of our effort is in data collection. But many of the most important things that we could collect data on in hydrology are being entirely neglected by the survey. Why can't we look at our data collection program and analyze it and say, are we spending our time the right way? Is this NACWA program really worth it when all of these other things are being neglected? That's a perfectly reasonable question. And I doubt whether those questions are being asked, simply because you can get the money for it. Say, oh, if we can get the money, it must be worthwhile. We are letting the budget, as I said before, run our program instead of us running the program from a scientific standpoint. I maintain that if you looked at the kinds of things that are going on in landscape, in hydrology, water resources in general, we would find that many of the most important data collection programs that we might have, which would not necessarily be expensive ones, are the ones that are being entirely overlooked, and we are spending money to repetitively do things that really we don't know what we're going to do with when we get it. I strongly urge that the program of data collection in the division be re-examined. Many aspects of it, let me give an example. Many aspects of the data collection program need review. I remember how absolutely astounded were the people in the water quality branch with regard to the following incident. Government agencies and government officers, as you know, don't like to be criticized. We all know that. And our reaction to criticism is often not a reaction that we're very proud of. I was invited to go to a water quality meeting someplace in the Midwest, I think it was St. Louis. And I had never met this man before from Michigan. His name was Jack Kinney. Later became a very close friend of mine. And Jack Kinney stood up before all these water quality people and he said, "You guys are on the wrong track." He said, "You know, you've got all these water quality programs going around, but you have no quality control as to what you're doing. You don't know whether your laboratories are giving you results that are correct. Why don't you have a quality control program," he said, "where you had a central laboratory that took in, at certain specified intervals, unknown samples and ran them and compared the results from a central laboratory with the laboratories that were running the same samples elsewhere." Well, I listened to this and I said, "My goodness, we're certainly not doing that at all, are we?" And I said to the chief of the water quality branch, "This is a very good idea. Get on it. Start a program of analyzing your samples through some kind of a system by which you have a quality control to find out whether all of our laboratories are giving us the right result." Well, now here was a matter, you see, of somebody coming in and criticizing our program, having to do with things we know the most about, data collection, and saying, "Look, you fellows are not thinking about some of the things that you need." And boy, we got on top of it. Immediately, the Quality Water Branch did exactly what Kinney told us to do and greatly improved our program. We had a lot more confidence after that that our quality samples were being correctly analyzed. And as I give this as an example to say that no matter how expert we are, we can always re-examine our program and say, is this program being done the best way that we know how? And it often turns out that we could improve it. And I say with regard to our data collection program, considering the fact that it's 90% of the total. And what is our total program? It's something many millions of dollars. Who is examining what we're doing? Who is asking the question of, are we really spending that money the right way? What else should we be doing? Wouldn't it be better to spend a little money on some of this other thing that we're not doing? So that it doesn't apply merely to the research program. I think that there's much to be said for a re-examination, either continuous or at intervals, of the major part of our program, which is the water sources program, to find out whether we're doing what needs to be done most for the nation's benefit, whether we're putting out the data in the right way, whether we're publishing it in the proper manner. But I'm saying a re-examination. I have the feeling that we get to a position where we know so much about data collection that we must be doing it exactly right and that no one can criticize us. And if we don't criticize ourselves, one day we'll find out that we're going to wish we had done something in a different manner.